Hello everyone. Have you ever wondered why noise-cancelling headphones are such in high demand? It's because they have the capability to exclude any unwanted sound or noise from the surroundings, where this surrounding noise can interrupt to whatever it is they are listening to. What if I tell you that we can use the idea in many other industrial applications? So that is what I'm doing in my research, which is controllable sound absorption of flexible magnetoactive foam. My name is Hilmi bin Rozaini, and this is my presentation. This flexible MR foam is just like a sponge. It has sponge-like material, but it has magnetic properties, which makes it a smart material. It has a potential in many applications, such as in sensors and actuators, robotics, and many others which requires noise reduction properties. Now, why do I focus on the flexible MR foam? Because previously, one of the researchers had investigated experimentally on rigid MR foam, and it has showed a promising result for, for, for further investigation. I was interested to exploit the noise reduction capability. Thus, choosing a different variety of the same material sounded like a good way to go. From previous studies, rigid foam are brittle, but they are proven good for middle to high sound frequency range for absorption, whereas flexible MR foam is malleable and bendable, but there are limited studies on its sound absorption properties. Does this further intrigue my curiosity to investigate and to know more on its sound absorption capability? Since in my research, I would like to do a comparison study on the flexible MR foam with the rigid MR foam. In order to do so, I had to first fabricate using the same method, which is using the in situ method, where the CIP content will be embedded into the microstructure of the foam. Thus, using the in situ method with the same CIP content in each sample, which are 0%, 35%, and 75%. The materials that will be used are the PU foam, the PU which is polyurethane, the CIPs which are carbonyl ion particles, which are iron powder, the polyether polyols reactant, which is a reactant, the polymethylene polyphenol polycyanate agent, or we call it PPP. After fabrication and after fabricating the samples, the characterization on the morphological behavior was conducted. This is to determine the pore size distribution in the microstructure of each sample. We use the SAM microscope for this characterization. As can be seen here, 0% the sample with 0% CIP has a pore structure that is quite large and relatively larger compared to the sample that has 75% CIP, where the pore size for the 0% for the sample with 0% is about 600 micrometer, whereas for the sample with 75% has a pore size of 300 micrometer, meaning to say the the sample that has 75% of CIP has smaller porous structure compared to 0%, the sample with 0%. Next is the sound absorption test, where we can find out more on the sound acoustic coefficient and the range of frequency that it can absorb. We'll be using impedance tube for this experiment, and the result will be shown in graph. Based on the test, it can be seen that the sample with greater CIP content has lower sound acoustic coefficient, and it is shifted more towards the lower frequency range. And you say as the CIP content increases, the acoustic absorption properties also increase. I believe the experiment outcome shows a positive result for my study on the flexible MR foam. This is because in comparison to the rigid MR foam, the range of frequency is for the rigid MR foam, the range of frequency is from middle range to high range, where you can be seen in the table. The lowest frequency it can absorb is 2500 Hz to about 5500 Hz, whereas for the flexible MR foam, the lowest frequency it can absorb is 700 Hz, about 704 Hz to about 944 Hz. This shows that the flexible MR foam has capacity or capability that it can absorb sound frequency range lower than 1000 Hz, which belongs to the lower range of the frequency. The SC for the flexible foam shows generally has a higher trend compared to the rigid MR foam. Which means to say that flexible MR foam has a better or has more sound absorption properties. It can absorb sound more. It has more sound absorption. Okay. Therefore, to conclude, from my findings, I think that flexible MR foam has a greater potential than the rigid MR foam for various reasons. One is the SAC, where the flexible MR foam has a generally has a higher SAC compared to the rigid MR foam, which means to say that the flexible MR foam has a capability to absorb sound, has a sound absorption properties better compared to the rigid MR foam. As we can see from the graph, for the frequency range, the flexible MR foam can cater for frequency range lower than 1000 Hz, which is quite difficult to achieve compared to the rigid MR foam, which caters around 2500 Hz to about 5500 Hz. Therefore, due to these findings, I think that the flexible MR foam has greater potential than the rigid MR foam. especially for various industrial applications, especially the ones that require some adsorption properties. That is all from me. Thank you for listening.